Let me do a tutorial of second order homogeneous differential equation. Example: y double prime minus 4y times y prime plus 3 times y equals to 0. Solution. Step 1. To change the equation into differential operator, d square minus 4d plus 3 equals to 0. For the second derivative I put d square, and for the first derivative d. There is no derivative term here, therefore I just put 3 here. Step 2. To find the roots. Can I factorize this equation? Yes, I can do factorization. Just factorize it to have d square minus d minus 3d plus 3 equals to 0. Solve the equation, and finally I got d sub 1 equals to 1 and d sub 2 equals to 3. These are the roots that I got in step 2. Step 3. There are certain rules that we discussed in the previous lecture. If the root is real and d sub 1 is not equal to d sub 2, then I'm going to use this equation. If the root is real and d sub 1 equals to d sub 2, then I'm going to use this equation. But if the root is complex root, then I'm going to use this equation. Look at here, my d sub 1 equals to 1 and d sub 2 equals to 3. So d sub 1 is not equal to d sub 2. Therefore, I'm going to take this equation, which is y equals to c sub 1 times e to the d sub 1x plus c sub 2 times e to the d sub 2x. Substitute the value of d sub 1 and d sub 2. The value of d sub 1 is 1 and the value of d sub 2 is 3. And this is the final value in step 3. Y equals to c sub 1 times e to the x plus c sub 2 times e to the 3x. That's how we solve second order homogeneous differential equation if the roots are different. One more tutorial of a second order homogeneous differential equation. Y double prime plus 4 times y prime plus 4y equals to 0. Solution. Step 1. Change the equation into differential operator form, d square plus 4d plus 4 equals to 0. For the second derivative term I have d square, and for the first derivative term I have d. Here is no derivative term, and therefore I simply put 4. And remember, they always set to 0. Step 2. To find the roots. Can I simply factorize this equation? Yes, I can factorize it. Just do factorization here to have d squared plus 2d plus 2d plus 4 equals to 0. Solve it further, and finally I got d sub 1 equals to minus 2, d sub 2 equals to minus 2. These are the two roots that we got in step 2. Since d sub 1 equals to minus 2 and d sub 2 equals to minus 2, and therefore d sub 1 equals to d sub 2. So I'm going to take this equation, y equals to c sub 1 plus c sub 2x into e to the d sub 1x, because d sub 1 equals to minus 2 and d sub 2 is also equal to minus 2. Just substitute the value of d sub 1 here, which is minus 2, to get the final value in step 3, which is y equals to c sub 1 plus c sub 2 times x into e to the minus 2x. Let me do one final tutorial of a second order homogeneous differential equation, which is y double prime plus 4 times y prime plus 13 times y equals to 0. Solution. Step 1. To change the equation into differential operator, which is d squared plus 4d plus 13 equals to 0. These are the rules at the right side. But look at here. Can we simply factorize this equation? No, it is not possible to simply factorize it. We're going to use quadratic equation here. Let me use quadratic formula here, which is minus b plus minus b square minus 4ac under the root or 2a. The value of a is 1 here. There is a 1 in front of d square, but we don't write 1. And the value of b is 4. The value of c is 13 here. Just substitute the values here. After simplification, I got the roots in complex form, minus 2 plus minus i3. If you compare it, minus 2 is t sub 1 and t sub 2 is 3. And therefore I will pick this equation, y equals to e to the t sub 1 into c sub 1 times cos t sub 2x plus c sub 2 times sine t sub 2x. Substitute the value of t sub 1, which is minus 2, and t sub 2, which is 3. Here is the final answer for step 3, which is y equals to e to the minus 2 into c sub 1 cos 3x plus c sub 2 times sine 3x. That's all for second order homogeneous differential equations.